What's up? What's up? It's Mr. Thompson with a maths video lesson going on with probability and talking about dependent and independent events. What are they? What's the difference? And how do we do calculations of probability with them? We'll look at some examples. Should be a fairly quick one. So we're going to start with independent events. Independent events are multiple events, multiple things that can happen that do not affect each other. They are just separate and independent, hence the name. Things like tossing a coin multiple times or rolling dice or multiple coins or multiple dice. The roll of one doesn't affect the roll of the other, right? One, you can get a result with one coin or one dice and then roll it again or roll a second one, and they're totally separate. One thing doesn't affect the other, okay? In order to calculate the probability of two different particular events happening, then these events being independent, right? If two events are independent, then the probability of them both happening, so probability of A intersection B, in other words, A and B both happening, then what you do to find that, you take the probability of A times the probability of B. So for example, rolling heads, if we want to get a heads, and then we want to get a second heads, we would say A is the first heads and B would maybe be the second or whatever, or a one on one and one coin and one on the other coin or whatever. Getting a heads is a half. The probability of getting is 1/2 or 50%. And same with the second one. So on half times a half is a 1/4. Or if we look at an example with dice, okay, if A equals rolling a 6 on one dice, very similar to my two heads in a row, and then event B is getting a 6 on a second dice or on the same die or whatever we say, the same die the second time, right? Those things are independent. They do not affect each other. So the probability of A intersection B is the probability, well, first we need to find the probability of A, which is of course 1 out of 6. This is just a normal 6-sided dice, numbers 1 to 6. So getting a 6 is 1/6. Getting a second 6, not affected by the first one, it's also 1/6. So to calculate the probability of both of those things happening, we do 1/6 times 1/6, which is 1/36. Sorry, tongue-tied there for a sec. Okay, hopefully that makes sense. If you have a more complex example, let me know. Happy to make more example videos here of this kind of stuff. Now, dependent events, as you might be able to guess, are events where one thing affects the other. Okay, and this is the kind of thing where you're drawing stuff out of a hat or drawing stuff, maybe drawing a card from a deck of regular playing cards, that kind of thing, because when you take one thing out, then that affects what is left to be drawn on subsequent draws. If you keep drawing cards, well, the ones that you've pulled out are gone, and now you have a different set to draw from. Okay, so one thing we specify with this kind of thing is that it's without replacement, right? We're drawing a card out of a deck. If we put that card back and then draw again, then the events are independent. But if we take the card out and keep it, then we can no longer draw that card, and that changes what options there are for the next time. So let's look at an example of that. Okay. Let's say we want to find the probability of drawing 2 hearts from a deck of cards. So a deck of cards, 52 playing cards, and there are 4 suits: spades, clubs, diamonds, hearts. We want to find the probability of pulling out 2 hearts, or let's say 2 hearts coming up, in a game or something like that of cards. So the probability of drawing a heart is 1/4, right? Because there are 4 suits, equally distributed, equal number of each. So 1 out of 4 cards is going to be a heart, or the probability of getting any one heart. Okay, so the question is, can we just do our 1/4 times 1/4 to get the probability of getting 2 hearts, right? Well, no, we can't, because these are not independent events. Again, assuming that we haven't put the first card back in before we get the next one, right? We need to think about getting that second heart. What are the chances? Well, there were 13 hearts to begin with, right? 52 divided by 4 is 13. And so once we've pulled one out, there's only 12 hearts left. So it's going to be 12 out of 51, because there's normally 52 cards in a deck. We've pulled one out, so it's 12 out of 51, rather than just 1/4 again this time. So we can now multiply those together instead of just the 1/4 times 1/4. This is fairly easy because we can cancel the 12s the 12 with the 4, that is. We get 3, so the answer is just 3 over 51. And that doesn't simplify. If you want to compare that to what it would be had we put the heart back, that would be this right here. So that's 1/16. And if we change the top to 3, 1/16 becomes 3 out of 48. So you have a slightly better chance of getting a heart if you put that first one back in, which makes sense because there's more hearts you've pulled. If you've pulled one out, then there's fewer hearts, so it's slightly less likely that you get that second one, and so on and so forth as you keep pulling hearts out. All right, well, that's it for today. Nice and easy. If you have any, like I said, more examples, feel free to request them in the comments or let me know somehow. Happy to make more videos. So good luck, and I will talk to you next time.